Good afternoon, everyone. For those of you who don't know who I am, my name is Anthony. I am the owner and founder of Puget Sound Stormwatch, both on Facebook and YouTube. First thing that's going to stand out to everybody is this huge Gulf of Alaska trough. This is a massive cutoff low that's separated from the jet stream, and it's having a huge influence on our weather over the next couple of days. What this is going to do is the south side of this is going to start bringing in unstable air to the upper levels of the troposphere, the layer of the atmosphere where all of Earth's weather occurs. This is a current look as of the 3 p.m. forecast. So what I want to do is go ahead in time a little bit. Let's go to midnight tomorrow, and we're going to watch this area right here. So let's zoom in just a tad bit. This is going to be the initial area of interest down here in southern Oregon, northern California. Yes, we're now just past noon here tomorrow. You're going to start to notice this feature start to form down here. Keep your eyes on that. Should also mention that this is the 500 millibar layer, so about 18,000 feet above sea level. This is 10 p.m. Wednesday. This is midnight Thursday. So now this is where the area of interest is starting to organize. So 7 a.m., 9 a.m., this has a little bit of a cyclonic spin to it. It's starting to develop upper level cyclone characteristics, and it's got this sort of tilt to it. It's starting to move north at this time. So this is 2 p.m. Thursday. This is about when all the action is supposed to start around here. 4 p.m., 5 p.m., skip ahead to 7 p.m. I should also mention that this is what the European model says. This is not the same as what the North American, and European AI models are saying. Now, the big thing I want to show you guys, this is the NAM 5cam model here on Windy. As of 3 p.m. now, it's going to have a much higher resolution and give you guys a much clearer picture of what's going on in the upper atmosphere. See the spin starting to develop over here over eastern Oregon. Not much in terms of moisture quite yet. This is 10 a.m. Wednesday. Now watch from this point on. Look in southern Oregon, northern California, northwestern Nevada. Watch as these winds come screaming out of the south. This is Thursday at midnight. It's got a clear as day spin now. 6 a.m. Thursday. And also, as of recording this, I just figured that the Facebook page has just hit 12,400 followers. So thank you guys. Thank you guys so much for that. It truly means so much. I can't even begin to formulate words for how much this means to me, considering around this time next week we'll be going full time on Puget Sound Stormwatch. Now, 9 a.m., 10 a.m., see this huge spin coming up from the south. This is 2 p.m., we're starting to get those southeasterly winds aloft coming in off the Cascades. That's going to steer any storms that do form over this area into the lowlands. In particular, we're looking at the eastern, mainly the southeastern lowlands, the foothills, and possibly parts of Seattle up to Everett. This is 3 p.m. as of Thursday. And 5 p.m. So the center of this low is right over Portland right now. And we have some isolated pockets of strong south to southeasterly winds coming in at about 18,000 feet, just in time for seafare practice. And this is the end of this model run, so 11 p.m. And then this is when the storm activity is expected to start winding down around the area. So now at this point, we start looking at some weather models. So of course, WeatherBell Premium is my go-to. This is the NAM 3KM 18Z run as of 11 a.m. It's the freshest model off the press. Now keep an eye on this activity coming up from the south. This is Thursday at 8 a.m. Pacific Daylight Time. There's a few discrepancies with the new run and the old run. The 12Z that was posted earlier this morning. So I'm going to be comparing those two here in just a moment. But one glaring difference that has jumped out at me first off is the timing of the storms is different on this run, but also the intensity and the location of the storms. This is going to have huge ramifications on who gets any sort of thunder chance. And of course, the Blue Angels practice is huge because these storms are going to be moving in right around the same time. We got the 18Z on the left, the new one, and the 12Z, the previous run, on the right. Get everything in sync. And we're going to put this into motion real quick. First off, we had some isolated cells perhaps popping up here earlier on in the morning time. See, not much in the South Sound here on the new run, but a few maybe pop-up cells ahead of the main event here in the previous run. Then in the previous run, we had quite a few areas of rain here in the southwest interior, while this just has isolated pop-up showers. This is as of 6 a.m. Thursday. So 9 a.m. Thursday now. New run doesn't have much in terms of precipitation down here, while this already has thunderstorms coming into Lewis County. Then this is as of noon Thursday, as perhaps maybe a supercell, an isolated supercell here just to the southeast of Mount St. Helens. Just remember, this is the old run. The new run does not have that. And then this is 2 p.m. 2 p.m. Huge, perhaps supercell here over Chelan County. Maybe some isolated cell, perhaps some multi-cell activity going on here in the South Sound. This is what I recently posted on my Facebook page. This new model run does not have any of that. Going on through the day a little bit, this is 3 p.m. This has really strong, perhaps isolated supercell activity going on down here in Yakima County on the new run. Does not have this on the old run. It has most of the storm activity up in Chelan County as well as the south to central Puget Sound. Once again, completely bone dry here in the central Puget Sound on the new run. It has a lot of rain showers, perhaps some isolated hail showers, maybe a couple claps of thunder, maybe even a lightning strike if you're lucky here along the south to central Washington coast. Now this is 5 o'clock. 5 o'clock, this new run of the NAM 3KM wants to bring the main round of activity in around this time, while the main event's already been done in the old run. And then this is probably around the time it's going to cut off. Yes, so we've hit the 60-hour mark on the previous 12Z NAM 3KM, so this model expires at that point. So now we go just to the new model from this point on. So this is hour 54, 0 Zulu time, which is 5 p.m. Pacific Daylight Time, Thursday. 6 p.m., 7, 8, 9, 10. And then it ends at 11. So now I'm going to rewind this back a little bit, and we're going to go through it one frame at a time. This is noon, 1 p.m., maybe a stray cell over Mount St. Helens. 2 p.m., not much organization going on. 3 p.m., we start to see these cells pop up over Yakima County, the eastern foothills of the Cascades. And then 23, this is 4 p.m. So 4 p.m., we start to get the strong cell activity about to cross the Cascade Crest. And then we have some isolated storms, maybe one over Mount Rainier at this time, one right over Snoqualmie Pass. So do be advised, if what this model is saying does verify, this is 6 p.m. on Thursday, could have some trouble getting over the pass at this time. 7 p.m. and then after that, my guess is this just hits the huge stable air mass that's over the Puget Sound at this time. and then everything just kind of vanishes. So this goes out to the storm lovers out there. I'm a little bit nervous now with this new model run, and I'll be very interested to see once the HER 3KM starts getting into full range of this. Let's go check out the HER 3KM here at the moment. So it's rendering the 21Z, which is one of the 18-hour runs. We want to go back to the 18Z, the most recent 48-hour run. So every 6 hours from the HER 3KM, we get a 48-hour run. Let's go, this is 1 p.m. Wednesday. So it has some isolated cell activity popping up over eastern Washington. Some of the Cascade Crests here tomorrow afternoon, but it doesn't do very much. See, it just disappears as quick as it formed. Now this is 12 a.m. midnight Thursday. And we start to get some of that isolated pop-up shower activity here in the southwest end. Some over Pacific County, southern Grace Harbor County, some of the I-5 corridor over Lewis and Cowlitz counties. This is 7 a.m. now. And the run goes out to 11 a.m. Thursday. And not much to be thrilled about right now. So I'm going to wait for the 0Z to come out. This should start rendering at around 6 p.m. I'd hope. Should be the 5 p.m. run, but it usually takes about 1 to 2 hours for it to fully initialize. This is the exact same story that Weather Bell just showed, except now we're on Pivotal Weather. One thing I like about Pivotal Weather over Weather Bell, other than the user interface, is the point sounding. So let's go ahead and pick this little cell. This is O2Z, so this is 7 p.m. Thursday. I'm going to go ahead and pull a point sounding down here in the South Sound. And it's just not looking great for storm activity. So this white dashed line, this is the parcel temperature. So imagine you have a box of air, and these little 3 dashes down here, this is the air when it's not saturated. And then from that point on, it starts to follow what's called the moist adiabatic lapse rate. So this is how the parcel of air moves when it's saturated. And when it hits that point of saturation, this is called the LCL, or lifted condensation level. If this sounding is showing all the correct information, this is showing that these are extremely high base storms, like over 3 kilometers high in the atmosphere. This LFC, this is the level of free convection, and then this is the equilibrium layer. So this is approximately where the cloud tops are going to be. This is where your CAPE, or convective available potential energy, is going to begin. So your LFC to your EL, this area between the white dash line and the red environmental temperature, this is your available energy for thunderstorms to feed off of. And as you can see, at the surface level, there's absolutely nothing. So since these are going to be elevated storms, we want to pay attention to the most unstable, or MU parcel, seen right here. The CAPE values for that are 18 joules per kilogram, but we do have negative 16 joules per kilogram of inhibition. You do not want any inhibition, if as little as possible, for storms to develop, even elevated storms. So at this point, this is a 3,236 meter cloud base level. This is where the clouds are going to condense. And we have a lifted index of 1. You don't want a positive lifted index. You want a negative lifted index. This is the difference between the white line and the red line here at the 500 millibar layer, about 18,000 feet. So the difference between the two right at that point right there. And in this case, the difference is the red line is farther out ahead of the white line. You do not want that. Now the next parameter I want to check out, this LFC, level of free convection. So you need a source of lift to get the parcel of air up to the LFC. And after that, it'll move freely on its own. So this level is at 3,412 meters above sea level. And then the equilibrium layer is only 4,701 meters above sea level. So that's not great. You want the equilibrium level way up here for really high cloud tops and mature storms. In terms of shear, not very much in terms of shear amplitude. The change in direction is there, but the magnitude is just not doing so hot. Basically, we have no effective inflow shear whatsoever, but we do have a little bit of shear from surface to 3 kilometers. So between about the 1000 millibar level and the 700 millibar level, as seen here. So between these two layers here, we have 18 knots of shear, which is a little over 20 miles per hour. So not very much in terms of wind shear here in this level. So see these here, these are wind barbs. These show wind amplitude and direction with height. So the directional shear is there, but most of the wind doesn't kick up until after the 500 millibar layer. So these barbs mean about 30 knots southerly. So 30 knots, 25, 30, 25, 20, 15. Long lines are 10 knots, short lines are 5 knots. So now that I got all of that information out of the way, what is my verdict at the moment? We're still around 48 hours out from the main event if what these weather models are saying is correct. So originally on this previous NAM model, remember I was saying the previous run had us getting storms around 2 to 3 p.m. Well, this one has pushed us back into the late afternoon. So if we average those two out, we should, in theory, be seeing storms between about 4 to 6 p.m. if we even get storms. So the threat of dry lightning is there too, just because of the high base elevated nature of these showers coming in. There's not going to be much going on near the surface. So with all that being said, I'm going to wrap up this forecast briefing for today. I'm anticipating either another briefing tomorrow, or I'm going to have sort of an exclusive live stream early on to get some FAQ, answer some questions, and check out some model runs before the main event. I do plan on going live Thursday if all things remain constant. If the NAM 3KM and HER 3KM both start spitting out model solutions that shout thunderstorms at us, I will certainly go live Thursday afternoon after work. Thank you all so very much for watching. This was Anthony from Puget Sound Stormwatch. I'll see you guys for the next one. Have a great afternoon, everybody.